This is Pison Technology, Team Pison's presentation of our final capstone project. The title is Low-Level EMG Biosignal Acquisition. Our technical directors with Pison Technology are Tanya Wang, who's a URI graduate, class of 2013, and Jonathan Eagle. So this is the team for Team Pison Technology, myself, Hannah Morrissey, and Jayden St. Germain, both electrical engineering majors. The Pison company vision and overview. Pison's mission as a company began with helping patients navigate the world made smaller and more challenging by their disabilities. Working with the ALS community, they pioneered the use of EMG to translate data generated by body's natural physiological electricity into machine interpretable events. Pison's patented EMG machine learning algorithms derive neural intent 30 milliseconds before muscle movement occurs. Pison's project motivation. This project's focus is on neural interfaces that fixate on gesture recognition, translating data from the body's natural physiological electricity into interpretable results. They're trying to collect the most accurate representative signals as possible while filtering out everything else that we don't need. A complex understanding of biosignals is imperative in obtaining readings and being able to convert them into data. Our anticipated best outcome is a developed system that can filter out all ambient noise coming from wires, cell signals, etc., and be able to pick up on our body's biosignals, which are very low voltage. This will be achieved with the help of LT-SPICE simulation as well as testing on the physical circuits. As of the end of our project, we did not achieve our anticipated best outcome. We did achieve LT-SPICE simulation as well as some testing of the physical circuit, but overall have not met the ABO as we do not have a finalized system.
So these are the key team accomplishments. So to start off, we built the analog circuit using LT-SPICE. In order to complete this, we had to find a suitable instrument amplifier to put in the SPICE model that met the system requirements. After that, we had to perform sensitivity analysis of the circuit and see how it reacts to different inputs. We also had to do a lot of component research and gain familiarity with the components that we were using or swapping in place of other components in the initial data sheet. We then created Bode plots for the frequency cutoff, which happened to be around 100 hertz. We familiarized ourselves with the physical pizza board, which housed all 8 of the circuits. And we also familiarized ourselves with the test circuit that we were using to test the noise on the pizza board. On top of that, for noise testing, we also learned how to use a spectrum analyzer. This is a continuation of our key team accomplishments. We familiarized ourselves with the, noise and what noise is and how it will be affecting the circuit that we're working on. We worked with soldering parts onto the test board and the pizza board during noise testing in order to gain access to both different circuits as well as testing the noise through different parts like resistors and stuff like that. We did research on possible solutions to a problem that we ended up coming across where our pizza board kept separating from the test wire, the PCB wire, and we got a new wire in the mail, but it ended up being too big. And so then we were tasked with creating a second board, which would be used for testing purposes only, and it would be much easier to use. So in order to do this, we had to learn how to use Fusion 360 by Autodesk. We had to do research on guarding, as well as what it is and how it's going to be implemented into the circuit, because we need guarding so we don't get interfering signals in the wire, and so it's a low noise system. On top of that, we drafted possible designs for the redesign of the pizza board, and we ended the project working on creating another version of the board. So for the economic impact of Pison, they have an overall positive economic impact in the world. They were recently selected as a finalist for Fast Company's World Changing Ideas Awards in 2022. Pison's patented gesture technology deliver a hands-free and heads-up advantage to America's warfighters. The team at Pison thrives on solving the most compelling real-world problems, and they do this by pushing the boundaries of human-machine interface in a culture of openness, intelligence, and care. This is the aforementioned Bode plot with the frequency cutoff that we found earlier. As you can see, the cutoff frequency is about 100 hertz. And this is part of the noise testing for the pizza board that we were doing. We had several different inputs to the system, such as grounded input, and then a sinusoidal input of 20 millivolts peak to peak at 300 hertz. The picture on the right, that is the spectrum analyzer connected to the test board, which is connected to the signal generator, which gives it the 20 millivolt peak to peak input. And you can see on the screen, that is the noise measurement that we got there. And then on the bottom right, that is the physical board that we were using. It's very small, so if you can see like why it kept breaking, and that's why we need to redesign it for testing purposes because it's really tight to work on. But on the bottom, that is the good chart that we made with all the different noise measurements. We ended up completing all of like the measurements that they needed, like for this board, but we couldn't continue further with other inputs because we were unable to connect the board again because of the problems that we were running into. These are my technical accomplishments. I helped build the circuit, the final circuit in LT Spice. I helped perform like the circuit characterization. Um, I created the Bode plots for the cutoff frequency. And then after that, I familiarized myself with the pizza board and test circuit. And I familiarized myself with noise as well as how a spectrum analyzer works. I actually consulted with Mike on this because he knows a lot about noise testing and how these spectrum analyzers work. After that, I familiarized myself with like how to solder because I had never soldered before, and I ended up needing to solder various parts onto the test board in order for testing purposes. And then I identified the problem with the board. Well, it was actually the wire because the wire was too big for the board. We couldn't connect it, and so we were kind of stuck for a little bit. And then after that, like we researched possible solutions. And like looked at Amazon for parts, but that's when we were tasked with creating the second board in Fusion 360, and we familiarized ourselves with how to use it. We started drafting designs, but we did not come to a finished product because that is where we ended up leaving off.
These are my technical contributions and my technical tasks. So between our key technical, as a team, technical tasks and the tasks Jayden had just mentioned, our tasks kind of overlap. So I won't run through the whole list, but I think Jayden kind of touched upon our major technical tasks and contributions for this project. And finally, we'd just like to finish with our acknowledgements. We'd like to thank Tanya Wang and Jonathan Ego from Pison. They provided a lot of guidance for us during this project, and we learned a lot from them. And also Dr. Sunak and Mike Smith, part of the ELECOMP Capstone program. Huge thanks to them as well. Thank you so much.
All right.